integrations using partial fractions. The process of expressing a function in terms of simpler fractions are known as the partial fractions. This is normally done when a fraction seems to be quite complex, and presenting it in terms of the partial fractions will look much more simpler. These are the examples of partial fractions. When a fractions constitute of a functions divided by three terms, x plus a, x minus b, x plus c, the functions can be separated into three partial fractions. Each term there will carry a partial fractions, and there will be a constant a, b, c there. This constant number will have to be computed from the function f(x). In case that there are repeating factors, let's say x plus a power 3, the partial fractions will be x plus a power 2, and x plus a power 3. In case that there is power 4 here, there will be an additional partial fractions of x plus a power 4. The partial fractions will constitute at every level of the powers. In case that the factors are quadratic, the a and b here, in terms of the x here, it will be 1 degree smaller than this. As there are two factors here, the partial fractions will be divided into two. The constant a, b, and c here will later need to be computed from the f(x). The integrations using partial fractions is normally used when the function here seems to be too complex to be resolved by using the other methods. There are too many combinations of different functions which can appear in terms of the multiplications and divisions. Resolving it will be very tedious and complex. With that, integrations using the partial fractions is used. Let us see some examples of integrations by using the partial fractions. You are asked to integrate this. There are two functions here which appear in the form of divisions. Integrating this seems to be quite complicated. Then you try if you can solve it by using the partial fractions. Rewrite the equations into two factors here. Based on the principles of partial fractions for linear factors, each factors will carry a partial fractions. At this stage, you do not know the factors a and b here. You will need to determine a and b based on the functions here. With that, you try to combine the two partial fractions here. A is to be multiplied with x plus 3 and b is to be multiplied with x minus 1. With that, you are able to combine the two. Expand the functions. Group them in terms of the x and the constant number. Then you make comparison with the functions here. Based on the function here, you know that a plus b is equals to negative 3, and 3a minus b will be equals to 11. There are two unknowns here. Simultaneous solve the two equations here. You get A equals to 2, B equals to -5. Substitute back the A and B into the equations for the partial fractions. You get this. Hence, you know that these equations can be rewritten in the form of partial fractions, and you can integrate them separately. Integrating this will give you ln, and the constant will remain. Integrate this will give you ln x plus 3, and the constants will remain. Remember to add in a c at the end of the expressions. This gives you the final answer for these questions.